We're live, ladies and gentlemen. Welcome back to another live stream. This time I'm really too tired to get the camera in, so excuse me for that, at least for the stream. So anyways, let's share the stream real quick. Everyone live, please join my Discord server. You can find the link down in the description, discord.kodotaku.com. And if you want to share my channel with some of your friends, you could just say kodotaku.com, and there you go. Okay, Loop Luminary, welcome to the live stream. Are you in Discord, by the way, Loop Luminary? So let me grab the chat real quick. I've done some changes, well actually a lot of changes off camera, though there's still triangles. It's just like changes in terms of, you know, just refining the API and making it much nicer to deal with and so on. And so yeah, let's actually see how's that. Okay, let's go. Of course, I actually have finally published the repo. Let me see if I can actually get it from here. Doesn't seem like it. Let me go to github.com. No, alright. I got a notification while I was doing stuff in Roblox. Oh, I see. Cool. Alright, so we have Kodotaku engine here. Here is the link. I actually have published it. So today's stream, I'm gonna go through all the changes I've done commit by commit, and I'm gonna explain it all. So I may actually just go forward with this kind of thing, like basically doing everything I want to do off camera maybe, and then just explain it in the live streams. I think that would probably be more efficient, but we'll see. We'll see how it goes. Alright, so let's get going. So a game engine made using Rust programming language in modern Vulkan 1.3 graphics API, live on YouTube with modern features like dynamic rendering. So it's basically the playlist. I actually made a playlist here. There you go. Cool. With modern features like dynamic rendering, focusing on performance, cutting edge technology, and developer experience more than compatibility. Windows or Linux with Vulkan API 1.3 capable GPU driver. That's the compatibility, and contributions of course are welcome, especially bug fixes. Will be reviewed in next live streams. Anyways, so let me actually go through everything that we have done so far that I've actually changed. Okay, let's see what we got. Oh boy, oh boy, oh boy. So last stream we have ended it, I think, where second stream, I mean, fix out of date error in the swap chain, maybe this. Yeah, this. So like I ended it in creating the license, I think. Yeah, pretty much. So this is all the commits that I've done off camera. So let's start by the first one. It's pretty simple. So basically Theo Paris in my Discord server have tried the what is it called? Yeah, I've tried the application or the engine on Linux, and it actually gave him error out of date. And I thought that the only place that is possible is in the acquire next image. I'm not handling that error, so here I didn't bother too much. Just if there's any error here, please make the swap chain, mark it as dirty, and we return okay. And hello Theo Paris, welcome back to the stream. That's pretty simple change there, nothing crazy. Let's go to the next one. Basically I just merged, I think, the thing. Alright, cool. Now separate the engine from the crate into it. Now this is the first edit that I actually done off, well, second edit that I've done off camera. It said it all. So separate the engine from the crate into its own crate. So basically right now the actual engine is separate, right? from the application. So the application, like it's the main crate, but then the engine is its own separate Rust crate, right? And it's actually a library crate. So if you see here, this is the engine, it's a library, and this is the dependencies that it have. And then we have the app, of course. And the app right now, look what happened. So we just removed all those dependencies, moved them to the engine. And so the application right now only depends on the engine itself and the tracing subscriber. Right, so cool. Yeah, and just change some, like the path and stuff. But anyway, you could see the whole thing in the commit. Alright, did I change anything else? Let's see, src. So yeah, just some changes there. Cool. Yeah, nothing fancy here. That's basically it. Okay, next up I actually created rust.yml. So GitHub will make sure to actually build, once I push some change into the repo, it would actually go ahead and try to build it itself in Ubuntu, right? Because here it actually configured it for Ubuntu latest, right? So it would build it on Ubuntu and make sure that it's actually buildable on Ubuntu. That's the only thing there. What's next? I just created a README. And then the other thing is I added rust-toolchain toml file. And basically to make sure that we're using the nightly channel. It doesn't really matter, but I mean, why not? Okay, so this is the first crazy change. Fix image state layout tracking and abstract command buffer recording. Crazy stuff. Okay, so let's see. So a new file, commands.rs, and I've changed the render module, the swap chain module, the window render module, and the rendering context. A lot of craziness. Let's start with the commands module. This is a new module that I've added. And so we have a struct commands, which contains the context, arc rendering context, and the command buffer handle. Okay, so you create it by just passing in the context and the command buffer. And then what it does, it actually resets the command buffer and it begins the command buffer. Okay, and so after that, you get all the commands. So I moved the command functions from the rendering context to this module right here, to this struct commands. Okay, so like clear image right here, what you got is self, of course, and then you got the image and a clear color. And now all of these commands actually return self, a reference to self. So this is, I used here a builder pattern, and you're gonna see it looks very cool. So basically I did this so I can actually easily chain the commands, right? The command recording, which is going to be very cool. Anyways, so transition image layout. So as you can see, I basically took all those functions and we no longer need to pass in the command buffer because it's part of this struct. And of course we no longer need the context either. Which is great. So only the actual parameters that are really needed for rendering, And that's basically it. And of course I did add the other commands. And the other thing here is the draw function here. Same thing, but I actually made the vertices in the instances a range, right? So you could actually give it, so instead of having to give it like 4 values, one for the first index of the vertex, like one for the first vertex and how vertices count, and in like first instance and instances count. Now we actually just pass in a range, and then I calculate the count and pass it to the API. Same thing here, and then I add like the star here. Pretty much nothing crazy. So the submit function, So we just have a queue, wait semaphore, and a signal semaphore, right, with the pipeline stage flags. And defense, pretty much nothing crazy. This one though doesn't return back the self-reference because at this point the command buffer is done, you know. So that's cool. Let me see the other files now. Where is it? Okay, so commands and what else? Let's see. The rendering context. Okay, let's go to rendering context and see what I have changed there. I just changed the name. I removed those masks and stuff. And nothing fancy there. I added the sub-resource range there. And what else? So as you can see, I removed the clear image because we have added it in the commands module. And here, impl image. I added this reset layout function. You're gonna see why. Because right now I fixed the tracking of the layout. Beforehand, like it was just kind of hard-coded there. And also I have made some, what is it called, presets for the image layout states, right? So we have a general layout state. So like if you're confused on which layout state you should use, like which access flags and which layout and which stage and which key family and so on, you could just say general. It wouldn't be the most efficient one, but it would always work, right? So it's basically access memory read and write, and for memory. So memory basically all reads and all writes, right? So like color attachment write, transfer, whatever, you name it. Layout, the general image layout. The stage, all commands. So it wouldn't overlap any commands. It would wait until all the previous commands are done, and then it would allow you to go to the next commands. Key family ignored, of course. Color attachment, of course, color attachment right. This is basically before we do rendering. And color attachment optimal, and the stage color attachment output. The presentation, we're gonna need transfer read, present src khr, source khr, transfer stage. I'm not sure though about these ones. I should double check. But anyways, transfer destination, transfer right, transfer DST optimal, blah, blah. You got the point, okay? And for the default, though this one I have changed it later on. But yeah, just in defined layout state, cool. So that's what I've changed there. Let's go to the next one. So let's go to the swap chain, see what I've changed there. Okay. So I removed views because it's actually stored in the images right now. Notice that I actually removed the views, and instead of using storing a vector of handles to images, I actually have my own image struct used right now, which contains the views. Perfect. What else? Let's see. So self.images.drain. So we no longer say self.images.clear. We just drain the images, and then we destroy all the image views there. Nothing fancy. Okay. So what we have here, map handle. So yeah, just because I changed that stuff. And now here I actually, instead of just pushing the image handles, now I actually construct an image. And here notice that the allocation is none because I'm not in control of the allocation of this image. So I don't own it basically. That's why I said allocation none, which gonna make sure to not actually destroy that image. Anyways, the layout, it's just a loop preliminary. So the layout is just in defined state. The attributes, it's not really, we do not know anything. So I just said location unknown, GPU allocator managed, blah, 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 whatever. So I just filled in some attributes there. Anyways, what's next? Nothing fancy there either. Let's go to the next one. Sub-resource range. Okay, added sub-resource range there. Alright, so the render function here. So this is interesting. This is interesting. Let's see. There is a unified viewer. Nah, that kind of sucks. Alright, let's see what we got. Alright. So beforehand we had like the states stuff, and then as you can see it was all clunky and so on. That sucked so bad. So like you had to give it the old state and the new state. And then I update manually. I just hard coding the thing, right? What the? Yeah, there you go. So like you give it the old state and the new state. But now here you no longer need that. So you just give it the new state, and then it would track the state in the image struct, right? Here we're just using that preset of color attachment, as you can see, instead of putting it here. Cool. And now we're drawing the, so like commands, well, first of all, where we actually, yeah, we're getting a reference to commands, right? Then we're resetting the layout. So like at the start of the command buffer, we start with a layout of none instead of the layout that we have ended with it in the previous command buffer, right? In the previous frame, basically. So we actually reset it. And what's next? We transition the image layout. So we say commands dot transition image layout, and we no longer pass in the command buffer in the context. As you can see, just passing the render target and then the image layout, the new image layout state. Then we start rendering, and you can notice that I can chain right now these commands like this, which is pretty cool because of the builder notation. And then I use this draw function, and then I say commands.end rendering. And I pass in, so instead of passing nothing, I actually right now return the render target that we're talking about here. Okay, what's next? Same thing with the draw function. Now we say instead of self.context.device command set viewport command buffer 0, every time you have to pass in the command buffer and so on. Now it's very simple. Command set viewport, you give it the viewport, set scissor, bind pipeline, and draw. Notice it's way nicer this way. Pretty cool. So okay, that's pretty much it for that one. Let's go to the next one real quick. Window renderer. I think that's the last one we need, right? Yeah. So for the window renderer, let's see what we got. I just extracted the swap chain extent into its own variable. Cool. What's next? I extracted the graphics queue into its own variable. And now we do not need these image states variables anymore. And we just take the swap chain image, we create a new commands variable, then we use the render function of the renderer. We pass in the reference of the command so we can fill in commands, and of course click color and frame index. It returns for us the render target, and after that, like the render target that corresponds to this frame, this in-flight frame basically. And then we just chain commands here. So commands.transition image layout swap chain image to transfer this destination, and transition render target to transfer source. Then we blit the image, like we blit from render target to the swap chain image, and we transition the swap chain image to present state, and then we submit the command buffer. Notice how really readable this is and very concise instead of this monstrosity here that we had here. So yeah, that's basically the change there. Extract, image into its own module and change. So now we had a lot of functions and structs that corresponds to the image. I actually made its own, I made its own module basically, and I put everything there essentially. So yeah, nothing fancy. Image layout state. And this is the other thing is that I removed the default state of like the default implementation. I changed that to the actual generic layout that you could use for anything. Like instead of the undefined state, I used this guy right here for the default value. And for the undefined one, I just called it ignored, right? So that's pretty much it for that one, I think. Yeah, let's go to the next one, or the other ones. librs. Didn't change much there. Rendering context. Let's see. Yeah, as you can see, I just removed these ones and moved them to the image module. Now I'll move the image related functions to image. Okay. So as you can see, I removed those image related functions into the image module basically. So mod.rs, and I also added a format for the renderer. I forgot to add it before. Okay. New render target. Now as you can see, we're making use of the image new render target function instead of that other one. And instead of resolution passing in a tuple, I just passed vk extend 2d directly, which is cool. Destroy image, create render target. Yeah. I just removed those end saves because they're not needed anymore. What else? And yeah, there was a bug here. I think. Well, hold on. Actually, not here, but anyways. So right now we have a destroy function inside of the image, basically, that I used here instead of saying context destroy image. Okay, what else? There is a swap chain here. Self.format. It's quite hard to see what I actually changed. But anyways, window renderer. Self.render.resize. So as you can see, this was 49 minutes ago. Alright. Self-render resize with. So we just pass in the extents directly. Cool. Nothing fancy there. Now here we got the image struct, and notice that I have now the functions here. So instead of context.create image, now we have image new, and then you pass in the context. So that's pretty much it. I also wanted to store in the allocator, but that effed up everything, so I didn't do that. Because it's probably because of the order of destruction is incorrect if I do that. So no. Anyways, we have this wrap function that we use for the swap chain images because we don't own them, and the destroy function. Yeah, here was the bug. Beforehand I was actually like, hold on a second, I was destroying the image in both cases, right? But now I made sure that we only destroy the image when we actually have an allocation. So yeah. What else? Rendering context. Create image. Yeah, we just removed those functions, I think. So I think that's it, right? Probably. Now update some commands. Here I just updated Yeah, some commands. Let's see. So I just removed clear image because we're not using it. I thought I would use it, but I didn't use it, at least not yet. Here, blitz image. I decided to just give it the flexibility that it had, and then create another function called blitz image extend. This is the one that we had before as blitz image. And also I added the depth there. Now blitz full image, and blitz full image uses the extent of both the images, right, and does its job, right? So that's basically it for that one. Nothing fancy. Here I'm actually using the layouts that are tracked in these functions here instead of just hard coding it, which is great. And yeah, where's that thing? Blitz full image. So now we're actually trying to do blitz full image. Sub-resource layers. So here I created the function that would extract the sub-resource layers struct from the sub-resource range, because we're storing the sub-resource range, and basically sub-resource range is a superset of sub-resource layers. So yeah, and that's basically it. That's all the changes I have done. Now let me actually show you how the code looks at this point, because I'm pretty sure that was probably quite confusing. In fact, it was even confusing for me. But let me show you how the actual code now looks like. Let's go to the renderer. Well, actually, let's go to the window renderer, for example. Let me show you. So look at this. This is the whole commands recording and submission. So transition image layout, blitz full image, transition image layout, submit, and that's it. Very freaking small, which is amazing. So yeah. All right, so what we gonna do today? Good question. Let's try to make a cube, I think. I have no clue where to even start with that. So first of all, actually we need a vertex buffer, right? So currently we're actually like hard coding the vertices in the shader itself. If you notice here in the vertex shader, we're actually hard coding them. Let's try to make a buffer struct and fill it with vertices and pass them to the shader. So yeah, that's what we're gonna try now. Let's go. So where are we gonna put this frame? Now it depends. So the resources, you should put them inside of the frame if they're not read-only, if you're intending to actually change them from frame to frame, right? If the buffers, you will write them just once and then they will be read-only, like you wouldn't update them, at least in like you wouldn't update them, then you can actually put them in the window renderer directly, and like you can share them between the two in-flight frames or whatever, how much we have. That's basically the case. Now in our case, for the vertex buffer, at least for now, we're not intending to update it between frames, so we could reuse them between frames. So we don't have to put it inside of this frame struct. We could just put it whatever inside of here. Now before that, let me actually create a buffer struct really. So where are we gonna put it? Let's put it with the image basically. Rust file, attach a module buffer. Let's add it to GitHub and let's go. So struct buffer. So it's gonna have the handle, of course, as always, which is gonna be a vk buffer, and it's gonna need the let's see what else we're gonna need. We're gonna need some attributes as always. Buffer attributes. we're gonna need to store the rendering context too. So context, rendering context, and vacate device size, the usage, not the memory properties. No, I think that's it for now. Maybe we'll see how it goes. Anyways, and of course here we'll put in the attributes, and we'll also put in the, what is it called? The allocation, yeah. Well, not vacate mem allocation, what the heck? Say allocation. Cool. So let's see how we're gonna create this now. Impl buffer, public fn new. So you're gonna have attributes, yeah. And let's see what we're gonna get. Let's go to GPU allocator library real quick. They have an example there that I can copy. There you go. So bind memory to the buffer. Or I could just do it. It's pretty simple actually. Let's start by creating a buffer or a handle. So vacate, well, attributes dot context dot create buffer. Well, device create buffer. And apparently it didn't like that. Oh, well, let's actually say and save here. Let's go. Cool. And of course we're gonna need result anyhow result here. So use anyhow result. There you go. Result buffer be found. Alright, and finally we're gonna say okay self. Pretty much. Now that we got the buffer, let's get the requirements there. Context.device.get buffer. Memory requirements, yeah. Handle. And maybe we could actually store this, no? Alignment, I don't know, doesn't matter for now. Okay, next up we're gonna create an allocation. Don't I actually have an allocation there? Apparently not. Well, how are we gonna pass the allocator? Let's pass it here. So allocator and so we're gonna say allocator the allocate. Oh boy. Allocation description. Add the missing fields. So we have the name. Let's actually add the name to the buffer attributes. Actually, maybe not. I mean, I guess why not string. And we're gonna pass in the name. It's attribute.name, attributes.name. Requirements, then the location. So for the location, same thing, I'm gonna put it here. Memory location, import, make allocator mutable. Yeah, we're gonna need mutable reference to allocator. and here allocation scheme. Okay, so context size usage allocation scheme, and so we're gonna say attributes to allocation scheme. Linear, a buffer should always be linear. And then the location is attributes.location. And that's basically it for the allocation. Perfect. Now let's bind the buffer memory. And then, yeah, I think we're done with the initialization. Add the missing fields. Well, not here. Let's actually take this inside of the scope, and then let's add missing fields. Cool, lovely. Though it may be indeed useful to store the requirements, because why not? I mean, we can. So if we ever want it, we'll find it basically. So that's cool. Add the missing fields, and yeah. All right, so what's next? What are we gonna do next? Let's first of all create a buffer for the vertices. So window renderer. So first of all, let vertices is equal to fine. Let's create a struct vertex. Let's just go with position for now only. And that's going to be here where we're going to be using an algebra. So an algebra as NA, right? NA and vector 3. So instead of an array of floats, we could just use vector 3, F32, pretty much. Now position, what else? Yeah, for now this should be enough. And of course, you're gonna need repr C for this. Repr C, let's go. I do think that maybe we need bytemug here. Yeah, we do need bytemug. So we're gonna say bytemug pod and bytemug zeroable. We need these three traits to be implemented here. And so yeah, let's just make a triangle. There you go. And let's go with the vertex buffer here. Let vertex buffer is equal to buffer new import. Oh, why it's saying there's no oopsies, I see what's happened there. Let's make these public, and I probably need public here too. All of these, so I'm able to fill it. Anyways, so vertex buffer. So actually, let's do Control Z and let's import the right buffer here, the engine buffer. Now let's see. Mutable render the allocator. Let's make the render mutable. Really? What the heck? Hold on. So the render, what it uses the allocator for? To allocate the render targets. I see. see. I mean, okay, fine. Let's use the render allocator. Why not? And then the buffer attributes. Let's import that. And vertex buffer. Just say the into. Alright. Seems like there's no need for this. So vertices.length times size of vertex, so we can get the byte size, like the size in bytes. And then the usage flags is vertex buffer. Cool. Yeah, we're gonna need the staging buffer too. Let's actually start somewhere. Let's just make this CPU readable though, for now. So GPU only, CPU to GPU. Yeah, let's just say CPU to GPU for now. The allocation scheme, just gonna say GPU allocator managed. Right now, what else? So let's store this vertex buffer now. Vertex buffer, and then add the missing fields. Now I think we're good to go. So what else we gonna need? Yeah, we're gonna need to map it. So let's get the let data is equal to vertex buffer dot mapped, well, dot allocation, right? So we gotta access the allocation. Well, basically we need a new function in buffer where we're gonna have like pubfn write, let's say pubfn write self data well, we're gonna have a generic t, because why not? Data, and then we're gonna get the slice. So self.allocation dot mapped slice, mapped ptr, mapped slice, mutable. Yeah, we're gonna need mapped slice mutable, and then we're gonna basically do this, and you're gonna say copy from slice data. Alright, what's up? Cannot borrow. Yeah, it needs to be mutable here. Okay, so this is an option. Let's say context. Let's use anyhow context here, and let's make sure anyhow context is called something else. Alright, fine. So fail to map buffer memory and copy from slice data. That's basically it. If T does not implement copy, use clone from slice. It would. I do need copy and clone here too, yeah. Copy and clone. Unrecognized representation. Oopsies. Well, actually not here. Not here, yeah. My bad. Let's actually say derive, debug, clone, copy, and bytemark pod and bytemark zeroable. We may have a problem, an error here, I think, but we can fix it if that happens. Alright, so write data result. Let's try to use that function now. Vertex buffer, let's make it mutable, and then write vertices. As simple as that. Alright. Now, what we're gonna do, let's see if this actually works. So expected U8 but found that. So here we could use bytemark because it is expecting bytes, but this could be any t. So let's use bytemark to do this. Bytemark cast slice data. And so t needs to have bytemark pod for this to work, right? So we could say this, and let's try this. Required by bound. Okay, so this is the error that I talked about. The trait pod is not implemented for matrix. So this is why usually people don't use the mathematics library that they're using in the vertex struct. They actually just use raw arrays. But there is a little solution here, at least in algebra, which is to make sure to add, I think, bytemark feature for in algebra. So cargo add in algebra -- features derive. Oopsies, not derive. Bytemark, my bad. And there you go. So as you can see, the bytemark feature got added to in algebra, and now this should work now. Is the stream fine, by the way? The mic is on, no dropped frames, and oh boy, what happened? So source slice length 36 does not match destination slice length. So the source slice length is data, right? So 36 does not match destination slice length, which is the map slice 48. I think it's because of alignment, probably. Yeah. So how we can fix this? Let's see. Well, we could so here's what we're gonna do. I think we're gonna do this. Gotta make sure that it fits. So from the start to data.length times size of t, and that should do the trick, I think, to make sure that the slices are the same, even if the alignment is not the same. And there you go. Oopsies. Oh yeah, I forgot to actually destroy the buffer. So let's have a function here called destroy, and let's see what we got. So destroy buffer and deallocate. Well, free self.allocation, but we cannot move the allocation, so we have to make sure that this is actually an option. Unless maybe if allocation does have like a default. I mean, can I, hold on, can I do this? Can I do std mem take and what is it called? Self.allocation. Can I do this? The expected mutable allocation, but found oh yeah, my bad. mutable like this. So yeah, apparently I can do that, which is great. Alright, so that's how you destroy the buffer. Now let's make sure to destroy it here. So self dot destroy, well, dot vertex buffer destroy, and we give it the allocator. Perfect. Now we should not have any problems anymore with that one. Perfect. Now the real question is, can I actually make use of buffer device address here or no? What are the flags that we have, by the way? Q family indices. Let me see the flags that we have here. Buffer create flags. These are just for capture play. Nothing fancy there. I mean, we could create descriptors, but I'd like to try my chance at using buffer device address. So let's see. Self.context. Whoops. Why the heck I can't get the context? Oh yeah, the attributes context. Dot, what is it called? Device, yeah. Dot get buffer device address. Call to an unsafe function. Remove this build function here. So you could give it the buffer. And I think that's it, right? Yeah. And this returns for you a vacate device address, which is cool. Now let's see if this actually works. Let's get the address of that. Where is the vertex buffer, dude? There you, well, okay, here we go. Let's try to get it. Let address vertex buffer dot get or device address, just like that. Let's see if there's any errors. Oopsies, there is. So why was created with vacate buffer usage 2 vertex buffer bit, but requires usage shader device address bit. Oh, I think maybe it's required to be storage buffer. Or storage use buffer usage. Oh, hold on a second. Buffer usage shader. Sorry, shader device address. Okay, what about now? Okay, so that works. Great. So now we're getting the address. What's next? We need to pass this address somehow to the shader. And we're gonna use push constants for that, because why not? And let's see how that works. So where do we even start with push constants? Good question. It's inside, I think, the pipeline, right? Well, actually, no, my bad. Vertex buffer shouldn't be here, I think. Yeah, it shouldn't be here. It should be in the renderer, my bad. So let's actually just take this out of here. Well, this whole thing, right? And let's put them inside of the actual renderer. Alrighty. Where is that thing? Okay, cool. Alright, let's go to the renderer. And let's go to oh boy. Alright. So vertex buffer is a buffer. Import, and let's say let's actually paste the stuff that we've made earlier, and self the allocator, basically. Well, we don't have self. Well, we do have allocator directly. Cool. Buffer attributes, import, memory location, import, vertex. Oh boy, let's grab the vertex struct from here. Well, we also need an algebra. Yeah. And let's put this stuff, well, not here, my bad, in the window, in the renderer. And there we go. Allocation scheme, import, and let's make sure to destroy the vertex buffer after we're done. So device, self dot vertex buffer dot destroy, and pass in the allocator, and there you go. Though doesn't have any results there? Well, it does, it's just that we ignored it apparently. And wrap with okay, yeah. Well, what the heck? Oh. No. Just say okay like that. Okay. And there you go. Let's go back now here, and let's just say in wrap here. What else? Missing field, let's add that field. And of course, well, actually, you know what? No, let's not put this here. In fact, they should probably be inside of, like, hold on a second. Can the device address for buffer change? I don't think it can. No, the device address of a buffer in Vulkan is stable and does not change once it has been allocated. Perfect. Because otherwise that would have been crazy. So we can actually get it at the start of the buffer. So we're gonna have address, vacate device address, and we wouldn't actually need this anymore. We could just inline this function really. So after doing this, attributes.context and handle. So this is going to give us the address. And we could add the missing fields. And there you go. Now we have access to the address. Perfect. Alrighty, perfect. Let's remove this from here. Okay, cool. Now the real question is how we're gonna do this. Where's the pipeline stuff? Yeah, let's check out the the pipeline function. Create pipeline. So there's pipeline layout, which is the one that we want probably. Set layouts. Yeah, there you go. Push constant ranges. I don't even remember how this works. Let's see. Well, first of all, let's have a push constant struct. And how are we gonna pass in the address? Let's check it out. Let's see if it talks about this here. But before display a pointer inside another buffer and have fun. This address works similarly to a normal address, and you can freely offset as it is really just a uint64t. Okay, let's say vertex buffer address. I don't know. What is device address exactly here? E64, which is perfect. And let's do this stuff again. And here push constant range. So here the stage that you want to give the push constants to. In this case it's vertex shader only, and then offset 0, size of push constants as U32. Perfect. Now we have to see how we're gonna do this. So let's go to the GLSL thing here. Shader.vert. Alright, let's see. Let's just comment this stuff out. And let's see how we're gonna do this. First of all, we need this extension. I actually never done this, so I'm not even sure if this would work. Is the extension after the version or before the version? I'm not sure. Probably after. Can forward declare types, which is nice for data structures like linked lists. Okay. Can declare a buffer type as well. This is not an SSBO declaration, but it basically declares a pointer to a struct. Finally, we could place a buffer reference inside push constants and SBO, SSBO or UBO. Okay, let's actually get the uniform registers here, which is basically the push constants. So we need position references. Where is that? Position references. There you go. So I guess we need this too then. Read only buffer position. Now where is this position type? Which is this one apparently. So we forward declare, I guess, and then after that we do this. Okay, after that what we do. Vec2 positions. In our case it's Vec3 though, right? Yeah, Vec3. Let's see some other example which would allow us to see more. Vec4 color. So I guess then we don't need all that crap. This is the push constant data, my buffer. So as simple as that. I'm not sure why they have all this crap. It's probably because they want maybe an array of buffers here, which I may want later on, but not now. So let's just copy this instead then. Let's remove this stuff, we don't need it. So buffer, my buffer. Vec4 color. Well, in my case, Vec3 position. So this is like my vertex buffer basically, right? And then what? So I guess this vertex buffer, and so this is my vertex buffer, I would guess. Okay, and what's next? I say using the buffer directly from push constant as if it is an object. Okay, let's try that out. Huh? Hold on, what? No, so basically it's saying that we have to say registers dot vertex buffer dot position. This is not gonna work as I wanted because we do need an array though. So how can I do that? So maybe I have to just say this. No. And yeah, maybe. Let's try that out. So instead of positions, we're gonna say GL vertex index. Alright, let's see if this would even compile though. So registers or push constants. In fact, let's ask the AI and see what it's going to say. Is this correct? But there are a few potential editors to address. Colors array. Which colors array? Oh. No, never mind. Don't do this. Frag color, just say just set it to like yeah, whatever, red, fine. The shader code you provide looks most correct. There are a few potential editors to address. Should be a vec4. Ensure the GL position is correctly set as a vec4. Oh, my bad. I see. So this is a vec3. Why there should be a fourth? Okay. Okay, so is this correct? We don't have any colors, bro, anymore. Okay, anyways, let's just try to compile this and see what happens, pretty much. So glslc and devres /shaders /shader.virg -o dev, well, res, sorry, res /shaders /virg.spv. And honestly, I'm gonna put this inside of a script, I think. But anyways, so as you can see, it actually got compiled apparently. Is the alignment correct? Come on. Yes, the alignment specified is correct. In Vulkan, buffer references must be aligned to 16 bytes, which is the alignment requirement for STD. Data is correctly aligned for accident shader. I don't know, we'll see. Anyways, so now how we can do this, how we can pass this up. So where is the byte, so right now we changed the pipeline layout, and now we have to pass in the push constants where we're actually doing that stuff. Yeah, in the renderer, of course. So renderer, okay, let's go to the draw. There you go. Now here, before the draw function, so we need to actually add some command right now. Let's add fn set push constants. So device cmd push constant self.command buffer pipeline layout. Here the stage flags. And then from raw parts, what the heck is going on here? No. Just say data, but it wouldn't allow it, right? Because this needs bytes, right? Okay, cool. Then we can say bytemap cast slice instead of that and save craziness. Just say bytemap cast slice. Perfect. Now let's try this out. Let's go here, and before the draw call, you gotta make sure to set the push constants. No. What the heck is going on here? What else we need? The layout and finally the data. And the data is basically push constants. What the heck is happening here? There you go. Cool. Address is private. Sure, let's make it public, please. And I guess that's it. Let's see if there's gonna be any freaking errors. Expected found T. Well, cast. Yeah, just cast, not cast slice, my bad. Try now. The trade, oh my bad. Well, the data should be like this though. And then here we shouldn't pass in that, we should pass this. Now let's try this out. Oh yeah, let's add that. Well, where the heck is it? There you go. Well, not here. Here, yeah. Okay, bite mark pod. POD. Let's try now. Oh boy. Trade pod is not implemented for U8, which is required by U8 inhibit pattern. What the heck do you mean? Da, da, da. Let's try this. I mean, no errors at least. But it doesn't, like, there's no triangles either. Oh, that's interesting. Well, render doc would probably crash. Yikes. I mean, let's try it out and see what's gonna happen. It's probably gonna crash. Yeah, there you go. And I think I know why. So like, maybe we should actually enable some features. Hold on. Da, da, da. Where is that thing? Yeah, let's go to the render context pretty much, and let's go to the features. Buffer device address. Here, yeah. So buffer device address and also buffer device address capture replay, I believe. And also when you create the buffer, I think you have to add some extra stuff too. Dot flags. So there's the script device address capture replay. There you go. I believe that's what we need. Let's compile this up. And let's try here. No, it still crashes. Oh boy. This is wild. So now I have no clue why it doesn't work. Are these the only things that are needed for push constants? Probably. What about the pipeline? Let's see, vertex input state. No, we don't want that. Viewport state. Damn, now I can't even debug this. Well, that sucks so bad. Render doc device address. Buffer device address. Well, this is 2021 though. But whichever. Let's see what we got here. Ba-ba-ba. Righty position. I guess we're just gonna use the scripture sets instead, because this doesn't seem nice at all. If I can't launch render doc, I can't do anything, dude. Can you please modify our code so that everywhere to specify? I'm setting both. Oh, by the way, let's actually remove this for a second. Let's try to run it again. Launch. Oh boy, okay. So the validation layers was effing up with my thing. Okay, that's cool. Let's try now to print this. And see what's up. Okay, perfect. So apparently I just had to disable my validation layers. Alright, cool, lovely. So what we have here. Okay, but where the heck is my VKCMD? What? Oh, there you go. So we have push constants and there's 8 bytes. Can I see what are those 8 bytes or something? Or let's go to the buffer. Well, there's no buffer. Okay, so this is the mesh view. So the vertex input, of course, nothing because we're not using the regular vertex stuff. And whoa, G Gear, and welcome to live stream. Alaikum salam. Alright, so vertex output, there we go. So there is some vertex output apparently, right? That's cool. Is that correct? Hold on. So let's go back to our vertex or vertices. Okay, so it is actually there, right? No? Huh. So minus 0.5, 0.5, what? Well, something is strange here. So the third vertex is actually 0, apparently. 0.50 minus 0.50. Interesting. Interesting. You know what? To avoid alignment issues or whatever the heck that is, let's try to use vector 4 instead. Just saying. No, and let's say vector 4, vector 4, vector 4, 0. Well, actually 1, my bad. Right? And then let's come here. And instead of vec 3, let's go with vec 4. And let's remove this guy here. Let's try to compile this. And let's see. Okay, it works. So probably some alignment issues there. But there we go, we used buffer device addresses. That's cool. Lovely. Alright, so let's add color too. Well, hold on a second. What if I... Hold on. Vec4 position. So it was probably some alignment issues. But like, how can I actually use Vec3 then? That's the problem. How can I use Vec3? Maybe this buffer reference align thing, honestly. Enabled extension names, enabled extension count. Ooh, that's nice. So that means right now we can just say buffer 16, right? Let me make sure this works. Too many storage qualifiers. Oopsies. Let's try now. Let's see if this works. It works, perfect. Now here what he's saying is 64. He's using an alignment of 64. That works too here. But what if I have a Vec3? I don't understand, like I need to understand what the alignment means. I know what alignment is, but what alignment is here? And 64 here, it's probably because matrix 4, no? Yeah, alignment please. Make camera? Yeah, for sure, but we're still making first of all the vertex buffer, you know. Buffer reference align 8. Each buffer reference type is an alignment that can be specified via the buffer reference align layout qualifier. Okay. This must be a power of 2 and be greater than or equal to the largest scalar component type in the block. Oh. It defaults to 16 bytes. That is the base of must be aligned. Members can be aligned within the block using standard layouts and offset. But it should be a power of 2. Interesting. This, however, caused issues during rendering. Adds additional operator support to enable array indexing. I mean, come on, just tell me what's the problem directly. So maybe I can't actually use Vic3 then? Or what? Yeah, I don't think so. Yeah. So fine, whatever. I don't care. Vic4 position. Let's add a color, for example, too. So to add a color, you basically, is it Vic4F, right? Well, actually it's Vic3 too. Let's see the fragment shader. But we could make it Vic4. Why not? I mean, we're gonna be passing that anyways. So Control S for saving and Vic4 color here. I mean, Vic4 bytes. So like a float is 4 bytes, right? Yeah. 4 bytes times 4, so 16. So I guess 16 is fine here. Alrighty, and now frag color. Frag color, we changed it to Vic4 here. And so here we're gonna say same thing here. But instead of position, we're gonna go with color. And there we go. Now, let's actually compile these. Oopsies. Error. Array must be redeclared to the side before being indexed with a variable. Interesting. Array. Must be redeclared with a size before being indexed with a variable. What the heck? So I guess maybe it cannot be without a size if there is 2 fields. Huh. Like, let's say I do this, okay? Let's just say I do it. And I do this. What about now? Okay, so that actually worked. Huh. Interesting. So then I guess maybe I cannot actually put all my vertices in one buffer then. That's gonna suck. Yikes. But let's just try this anyways and see what's up. So render vertices So the color here, okay, and then let's add some colors. And now let's see if this works. Though, did I actually compiled both? I haven't. Let's go with the fragment shader too. Oops. There you go. Let's try now to run this, and we should have some colors. Uh-oh. Why it just hanged? What in the world? That apparently didn't work at all. So I guess we probably cannot like do two fields somehow. Yeah, apparently. So if that's the case, then this should be like a position buffer somehow. And then a color buffer. You'd have a second buffer just for color. Color buffer. Oh my god. We probably should just go with, honestly, with the regular, like how you do the vertex stuff without the buffer device address. This is wild. So push constants dot color buffer dot color. Oh my god, no, this sucks so bad. Yeah, no thanks. This sucks. Unless if I can find something that would fix this. Otherwise, I don't buy this. At least for vertex buffer. Transform data. Oh. Hold on. What the heck? Maybe. But no, how? Okay, let's try something interesting here. What if I actually said vertices like this, and I have, so this is gonna be my vertex buffer, let's say, and then this would be my, what is it called, my actual vertex, maybe. And so you would have like vertex here. And then Vic for color and Vic for position. Is that how it goes? Vertex buffer. And then vertex buffer dot position, vertex buffer dot color. Let's see if this even compiles. No. Oh, hold on. No such field in structure push constants. Position. What? glxc buffer reference to buffer reference indexing. Is there like maybe a way to do a struct? In GLSL? That doesn't seem to help either. Yeah, that doesn't help. Let's see if there's anything else. Items. Oh, struct, here you go. Oh, my bad. I see what's up. My bad. Vertices. Oh, vertices. Cannot apply to an array position. Well, my bad. Again. This should be here. This should be here. Is this how it goes? Well, I mean, it have compiled. So that's cool. Did I change anything here so far? No, I haven't. Cool. Let's try this out. Oh. I don't think that's the triangle we had before. I mean, it probably works, maybe, but there's just some alignment issues. Let's say 64 instead, or 32, and try that out. Still a problem, I think. Oh, okay, what about 64 then? Interesting. Nah. All right, if I go to here and let's see what we got. So let's go to pipeline state, vertex, well, mesh view. And let's go to draw function. Okay. And so this is the GL position we're getting. Is that the one that I'm giving it? Or is it something else? Oops. So no, I'm giving it minus 0.5. Oh, hold on. Position color. Color, oh. Oh boy. Oh boy, oh boy. Alright, so it actually works. Perfect. Oh my god. Let's go. So we actually made buffer device address works. I can't believe there's not that much resource about how to make this work. Or maybe I'm just too stupid. Anyways, at least I figured it out at the end. I'm glad I didn't give up. So there you go. Cool. Very fucking cool. Damn. Alright, so next up we probably want an index buffer too. That would be great. Though honestly, for a vertex buffer, is it really needed, dude? I think hold on. I mean, I don't remember what is the setup of like a regular setup of vertex buffers. Hold on. Let's see. Let's see what they do. The mesh class, I don't worry about meshes now. VMA map memory. Okay, vertex input layout. Bindings and attributes. Get vertex description. So you say binding 0, stride, size of vertex. Huh. So you have to do all this crap? But why? That's interesting. So I didn't have to do any of this crap. It's like just go directly to the freaking thing. Yeah, that's cool. No need for any bindings or whatever. Yeah. Yeah, let's just keep using, I guess, this. Why not? Cool. Alright, let's add an index buffer. How are we gonna do that? Or actually, before we add an index buffer, maybe let's do a staging buffer first, okay? So how are we gonna do this? Interesting. So basically our vertex buffer would become GPU only, so it would be stored in the VRAM, okay? But that means that we cannot actually, you know, write to it from the memory. I mean from the CPU, sorry. So we need a staging buffer. So let's say staging buffer is equal to this. And so field attributes instruct buffer is private. I mean, let's just say let vertex buffer size, or I mean, fine, whatever. Like, hold on. Okay, fine, let's go ahead and do this. So public and transfer src, and that means that this guy should be transfer dst, and so CPU to GPU, perfect. Allocation scheme, I'm not sure what the heck is that linear thing that they're trying to do, but there's like GPU allocator manage, dedicated buffer, and dedicated image. Anyways, so that's it for the staging buffer. Now we actually gotta use the staging buffer here. Make mutable. So we write into the staging buffer from the CPU, then we have to actually make a command buffer. And to make a command buffer, we have to, well, allocate it, of course. Did I make any helper function for that? I don't think so. Though I do think we have already created some command buffers, right? At this point. Did we? What? Oh no, not here. I see. So we're gonna need some command buffer then. And we don't even have a command pool here, right? Yeah. Interesting. So how are we gonna do this? Are we gonna have a command buffer for the render? Or maybe when we create the render, we request the caller to give us a command buffer. I mean, that's the easiest solution right now, I think. So let's just go with that, I think. Let's just ask the user for some commands. I think, and okay. Commands.copy buffer, staging buffer, vertex buffer. Now we have to implement that copy buffer. Staging buffer, vertex buffer. Okay, let's go ahead and do this. So let's add a new command here. Copy buffer. What the heck? Not image. It's a buffer, bro. And dst buffer buffer. Okay. Is private. Public. Dot size, source buffer attributes, dot size. Okay, cool. Cool. With that out of the way, what we're gonna do next? Commands. So let's actually go to the rendering, like the actual window renderer, yeah. Here we do have some command buffers, as you can see, which is great. Alright. Let's actually say let commands And we're just going to reuse one of the command buffers that we have, right? And then we can pass them to the renderer. And then let's make sure to submit them. So we're gonna submit them graphics. I'd rather go maybe with transfer, but whatever, it's fine. Don't wait for anything. Though we do need a fence. We need to wait for this to end. Or interesting. Well, we could make use of one of the fences. So context, no, frames, right? So we could make use of that then. Or let's just say let fence is equal to frames 0.inflight fence. And then what? After that, I'm gonna wait for the fence. So I'm gonna wait for the upload to finish, and then I'm gonna reset the fence. Oh boy, no, we do not want to reset it because it should be in the signaled state at first anyways, I think. Yeah, let's see what's gonna happen here. Right, let's see. Oh boy, crash. Access violation, reading location. Oh my god. Was created with transfer but requires. Oh, yeah. Yeah, I see. Let's go here. Well, not here, in the render, I think. So what's the error again? So pinfo buffer was created with usage to transverse src bit but requires shader device address bit. Buffer must have been created with vk buffer shader device address bit. Huh. I don't think I need it for the staging buffer, but like, whatever, just do it. Oh boy. Well, not really. Use this. Though I didn't. Oh, I see why. Because I am getting the buffer device address directly, right? Interesting. So I guess what I could do is maybe hold on, I have a little idea. So in the new function, okay, we could do this. So if, well, let address is equal to if usage, so buffer attributes dot usage flags contains vk buffer usage flags shader device address, then do this. Else default. Would that help? Let's see now if that's a problem anymore. General parameter error require handle. VKQ submit true, P submit 0 is vk null handle. I mean, yeah, I don't have any semaphores needed. So what? Let's see, copy buffer. Oh, am I actually submitting this? Hold on. Then I have though to submit this. And well, what submit requires? I see. So let's give it a queue. Which queue? Let's get the graphics queue real quick. Submit graphics queue, comma. What else do you need? You need a wait semaphore. So for that, we're gonna go with honestly default, and default. Well, I guess then I could just say default for this whole thing then, probably. And probably the same thing for the other one. And finally, what's the other parameter? Fence. Now here I do have a fence. I mean, I'm pretty sure. Actually, no, not here, dude. This is the freaking renderer. Oh my god. Rendering, well, window renderer. Wait for fences. Yes, I am doing this. And apparently it's not like in that I gave it semaphore null, I think. Huh. Let me try again. And let's see where this goes. Here. It's telling me that semaphore of wait is null. Oh, I see. So I guess maybe if it's null handle, then I shouldn't give it to it at all. Interesting. So let's grab this guy. And basically, let's grab this and say if wait semaphore, yeah. So if it's not equal to null, then we're gonna say submit I guess I should probably say this maybe. Make equal to submit. So this is mutable or no? It is mutable. Anyways, and then what's going on here? No, don't do this. Just that. And probably same thing here. So if signal semaphore, then to simply take this. There you go. I think that's basically it. Let's actually call this info instead. And let's see if that fixes it. Oopsies, creates temporary value dropped while borrowed. I guess probably talking about this. Yeah, I think so. So let's actually put this, let's say, in a variable. Maybe, and let's see now. Temporary values read at the end of the statement. Whatever, let's say let y, I guess. Y. Well, I probably want it to be here, maybe. And probably same thing here. Let's see if that fixes it. If fence is not vacant or handled, then fence must be signaled. I see. So. Let's then reset it. So device, well, context dot device dot reset fences. And let's go. Wait semaphore 0 queue is waiting on a semaphore that has no way to be signaled. Huh? Where this is the case, the present on image index 0. Oh, that's strange. Oh, by the way, did I reset the command buffer? Maybe I gotta do that. This is crazy. So then how can I Can I signal a fence immediately? Maybe that's the problem. Context.device. Well, you know what? What the heck? What I'm doing, dude? Why bother with this crap? You know what? Let's just create our own fence. Why not? And we do not need it to be signaled. So we have a fence. Yeah, let's try this out. What? I didn't touch that other stuff. What the heck? Oh boy. Okay, let's try to even create our own command buffer then. So where is it? Our own command buffer. Well, context, right? Yeah. So we don't have to reset anything here. So just wait for the fence. What the heck is going on here? I don't... Like, for real. I'm not even using any freaking semaphore. What the heck? Is it at least reaching this point? I do think it does. Yes, it does. So what's the problem then? Maybe? Hold on. Hold on a second. So where's the fence? What? Oh, bro, what the heck is going? Oh my god. I can't believe this. I just can't. Oh my. Alright, so how to do this? Command buffer submit info. Oh, this is what? Okay. Is there another problem? Expected. Well, fine. Oh, I see. Damn. Damn, this sucks. So I guess info. Is that what I need? What the heck is going on here? Bruh, I'm very confused right now. Okay, what about now? Come on, for real, dude. This is wild. Oh my god, finally. But now nothing is working for whatever reason. Let me make sure that what I'm doing here is correct. So this is our submit command buffer submit infos. Whoops. So well, command buffer submit infos. This is submit info. Okay. This is semaphore. Huh. So this is the wait semaphores, right? Yeah. Oops. Wait semaphore submit infos. And this is signal. Signal semaphore submit info. Cool. Well, actually infos. Alright, so if wait semaphore 0 not equal to null, then submit info. Wait semaphore infos, wait semaphore submit infos. If signal semaphore 0 not equal to null, then signal semaphores. Yeah, that seems about right. Then queue submit to submit info. Alright, so then what could be wrong? Maybe let's try to launch this. See what happens, I guess. Oh, it crashed probably. But I'm not getting any error here. Oh well. Okay, I think I'm already too tired at this point to function. So that was it for this live stream. See you in the next one. Goodbye, everyone.